Good morning, children. In our last lecture, we took up the topic of types of reactions in the first chapter of chemistry, which is chemical reactions and equations. We have already covered combination reactions and decomposition reactions. To give it a recap, combination reactions are those in which two or more substances or elements combine to form a single product. I have also discussed about some of the examples of combination reactions, and then we did decomposition reactions, which were divided into three categories: thermal decomposition, electrolytic decomposition and photolytic decomposition. Now the next category of reactions is displacement reactions. How do we define a displacement reaction? The definition of a displacement reaction is when a more reactive metal displaces a less reactive metal from its salt solution, it is called a displacement reaction. When an element displaces another element from its respective compound of lower reactivity, it is said to be a displacement reaction. One example of a displacement reaction is zinc plus hydrogen sulfide gives you hydrogen plus zinc sulfide. As you can see, zinc is replacing hydrogen and we get zinc sulfide on the other side, and hydrogen is released as a gas. So zinc displaces hydrogen. Another example, which is a very good example of a displacement reaction, is that we take copper sulfate solution in a test tube. The color of copper sulfate solution is blue, and put an iron nail into it. So we have metallic iron dipped into the solution of copper sulfate. Leave it for 1 week and the reaction takes place. What we see after 1 week is that the color of iron nail changes from brown to the green color is coated on the iron nail, and the blue color of copper sulfate changes to green colored iron sulfate. It is because copper sulfate is blue and iron sulfate is green, and copper is deposited on the iron nail. So which tells us that iron displaces copper from its solution and we get iron sulfate plus metallic copper. One more example of displacement reaction is aluminium plus copper sulfate gives us copper plus aluminium sulfate. This also shows that aluminium is more reactive than copper. Another example, iron plus copper sulfate gives copper plus ferrous sulfate, and similarly many more examples can be given. Coming to double displacement reactions. In double displacement reactions, we have two substances, two compounds taken in aqueous solutions, and there is a double displacement of ions. For example, we take silver nitrate solution and sodium chloride solution. We mix them together, and after some time we find that silver chloride and sodium nitrate is formed. So it is a type of reaction in which there is an exchange of ions between the reactants. Since two ions are exchanging their places, it is called a double displacement reactions. These reactions are also called precipitation reactions, as an insoluble substance is formed which is known as a precipitate. So in this reaction, AgCl is obtained as a precipitate. What is a precipitate? It is an insoluble solid which is formed in a chemical reaction, whereas sodium nitrate remains in aqueous solution. Any reaction that produces a precipitate can also be known as a precipitation reaction. Example of a precipitation reaction, which is also a double displacement reaction, is the reaction between silver nitrate and potassium chromate. We take these two solutions and mix them. After some time, we notice that a precipitate of silver chromate is formed in the solution of potassium nitrate. that is potassium combines with nitrate and chromate ions combine with silver, forming silver chromate, which is obtained as a solid precipitate and in the solution of potassium nitrate. The next category of reactions, perhaps the most important one, is the redox reactions. Redox reactions are a combination of oxidation and reduction reactions. Oxidation reaction is that in which oxygen is added to an element. So if a substance gains oxygen during a reaction, it is said to be oxidized, and if a substance loses oxygen during a reaction, it is said to be reduced. If one reactant gets oxidized, the other reactant has to get reduced. Such reactions are called oxidation reduction reactions or redox reactions. So oxidation is not possible without reduction and vice versa. If a substance gains or loses hydrogen during a reaction, gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen and gains hydrogen during a reaction, it is said to be reduced. We now take up examples of redox reactions. In this reaction, we see that sodium is combining with oxygen to give us sodium oxide. Now sodium is gaining oxygen because it is combining with oxygen. So sodium is said to be oxidized and oxygen is reduced. Another reaction is methane plus oxygen gives us carbon dioxide and water. Now in this we find that methane is combining with oxygen, forming carbon dioxide and water. So methane is getting oxidized to carbon dioxide because carbon is gaining oxygen, and oxygen is getting reduced to water because it is gaining hydrogen. Once again, gain of oxygen is oxidation, loss of oxygen is reduction. Gain of hydrogen is reduction and loss of hydrogen is oxidation. We come to the last topic of the chapter, which is corrosion and rancidity. Now what is corrosion? When a metal is oxidized by substances around it such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are examples of corrosion. Corrosion can cause damage to car bodies, bridges, iron railings, ships and other objects made of metals, especially those of iron. Corrosion of iron is a serious problem. In the picture, you can see the body of a car is getting oxidized and it gains brown color because the body is made up of iron, and as the paint loses its texture and the iron gets exposed to atmosphere, it gets oxidized, forms iron oxide, and we say that iron has got corroded. When fats and oils are oxidized, they become rancid and their smell and taste changes. Children, you must have observed that eatables, if they are kept in long for some period of time outside, then their smell changes, some foul smell starts coming out of them, and also their taste changes. This is because of rancidity, and rancidity happens because of oxidations of fats and oils present in the foodstuff. Mainly substances which prevent oxidation are added to food containing fats and oils. These substances are called antioxidants. Potato chips are often flushed with nitrogen gas to prevent it from rancidity, because nitrogen replaces air which contains oxygen, and in the absence of oxygen, the chips have a more or longer shelf life. So, we have also covered corrosion and rancidity. That is the end of the chapter. Children, please do the assignment which has been shared with you and submit the assignment as soon as possible. In the next lecture, we shall start with acids, bases and salts.